All right, so in this problem, we need to figure out what chapter this is coming from. That's the first thing. Let's figure that out. I can tell that this is a chapter 7 problem, just like the previous set of problems, because we are looking for a probability. Just looking right here, I can see that we're looking for a probability for a price, an X bar that is more than a certain value, or a price that is within a certain value. So this is telling me it's a chapter 7 problem. Okay, now that we've got that, let's get started on actually solving this problem. I think the first thing that you should do is write everything out, write everything that you have out. So what do we have? We have an average milk price of 3. So mu equals 3. What else do we have? We have a population standard deviation of 1.75. So I just am going to do sigma equals 1.75. All right. And we have a random sample of 36. So that means our n equals 36. Okay. All right. Now let's start looking at the actual questions. So 28, what is the sampling distribution of X bar when sample of size 36 is used? So this is something you should know. It's this is like the definition of a central limit theorem. If we're going to say this is normal due to the central limit theorem. That's something you should know. So it'd be B. Also, just so you guys know, a little tip, it's like in these 4 chapters that this exam covers, you haven't learned Chebyshev. Chebyshev was from like exam 1 or the chapters 1, 3, and 6. So it's not that. So that's definitely not it. And yeah, it's probably not going to be these ones. So anytime you see this, hint, it's the central limit theorem. Okay. 29, suppose that we reduce the sample size from 36 to 16. The sampling distribution of X bar will be normal only if X has a normal distribution. Okay. That's going to be the answer. That's because if you have a sample size of 30 or higher, you can make that assumption that you're going to have a normal distribution. But when it falls below 30, so to 16, for example, the sampling distribution of X bar is going to be normal only if X has a normal distribution. So yeah, that's how you get that. All right, so let's go to 30. What is the probability that a random sample of 36 supermarkets will provide an average milk price that is more than $3.50? First thing we need is standard error. So hopefully you guys remember this from the last set of problems that I did. You need standard error for these problems. Always need to calculate standard error. So let's first get our standard error. How do we calculate standard error? That formula is going to be standard deviation divided by square root of n. So standard deviation divided by square root of n. And in that case, we wrote all this stuff out here. So we're going to do 1.75 divided by square root of 36. And if you were to plug this in Excel, you're going to get 0.2916 and 6 repeating. Okay. And so we're looking for more than 3.50. That's the next part of the problem. So let's just set this aside for a second. We're going to be using norm.dist. That's the formula that we use when solving these problems, when solving these chapter 7 problems. So norm.dist. And because it's more than, guys, remember, we have to do 1 minus. So actually, let's just cross this out. It should be 1 minus norm.dist. And then what? Then we need our X value, which is 3.50. Then we need our mean. Our mean here is 3. Then we need our standard deviation, but instead of standard deviation, we do standard error, right? So standard error, we plug in this value. 0.29166, comma 1. And that's it. When you plug this in Excel, you're going to get 0.043, 0.0432. So that's going to be like 4.3%. That most closely matches with this. So that's going to be the answer. Okay. All right, let's move on to 31. So now we're looking for the probability that the price will be within 0.50 of the population mean. So what is the population mean? That is 3, right? So our population mean is 3. So we need our upper limit and our lower limit, right? What are the two values that we're using? So we need to add and subtract 0.50 from 3 to get our upper and lower limit. So this isn't too difficult. We're going to do 3 plus 0.50. And here we're going to do 3 minus 0.50. When you do that, 3.50. And here you get 2.50. All right. And when we're trying to find the probability in between 2 points, we use norm.dist of the larger value minus norm.dist of the smaller value. So what we're going to do here is norm.dist, and our larger value is 3.50. Then we need our mean, 3. Then what? Standard error in place of standard deviation. So standard error, we already calculated that above here. Okay, so 0.29166, comma 1. And then we're going to do minus norm.dist of the smaller value. So let's see if we can fit this here, 2.50, comma, and let's just go right here. 3, sorry, mean, standard error in place of standard deviation. And if you were to put all of this in Excel, you are going to get 0.9135. So you're going to get, let's just put it right here, 0.9135. And this is going to be 91%, right? So B. All right, so 32 says, the probability in the previous question were blank if we were to increase the sample size. So if we were to bring up our N, what is going to be affected? What I'm going to do right now is I am going to share my Excel just to show you guys this cool thing. So this is something that I already did. I have this calculated on Excel. This is everything that we just went over, all calculated out. But so we want to know what's going to happen if we change our sample size. So right now our sample size, our N, is 36. And we're saying, what if we change it to 72? So let's change it to 72. And I want you to pay attention to what happens to the probability right here. Because remember how we said we got 0.91. So let's watch what happens when you change the sample size to 72. Did you see that? So it just went up. We went from 9.91 to 0.98. So that means our answer is going to be increases. And I just want to point out right now that the only reason that this works, like changing this is going to change these, is because I use cell referencing in this problem, meaning I referenced this N value in all of these. So whenever I change this number, it automatically changes all of these for me. So if you're using cell referencing, this is something that you can do. I think it's very convenient. So yeah, let me stop sharing and let's go back to this. Okay, so we said that the answer would be B, increases.